Today's lesson is on Chapter 5, Chapter Review, and I'll be using the textbook starting from page 239. The first part, Lesson 1, we learned about identifying similar figures. So when do we know that two figures are going to be similar? The easiest way is to see if they're proportionate, if their ratios are going to be the same when you set two of these sides in an equation. So for example, number 1, I have two triangles and I need to see if they are going to be similar. So for example, on my first question, I have 10 and 8 that are corresponding, and I also have 6 and 5 that are corresponding, and you see if their ratios are going to be the same. If you can simplify it into a simplest form, you can compare it that. If not, you can cross multiply and see both of the numbers are going to be equal. In this case, I have 10 and 8, which I can simplify into 5 and 4. And I know that 5 over 4 is not going to be the same as 6 over 5 because I cross multiply and it's going to be 24 and 25. So the first question, they are not similar. For number 3, I have a pentagon with sides 6s and also 8s, and then the second one I have 3s and 4s. And if you still choose the corresponding sides, so 6 over 3, and that should equal to, let's choose something else, so 8 over 4. And you can either simplify the fraction or cross multiply and see if they're the same. In this case, when you simplify both numbers, they're going to be 2, so you can say that they are similar. When they ask you to explain your reasoning, it should include something like the ratios are equal. When you cross multiply, they have the same number, or if you multiply a certain number, it's going to be the second shape. So we have many different ways to explain it. The second lesson, we learned about perimeters and areas, and these are going to be represented using fractions, and they're going to be the ratio. For question 5, we have two figures. We have to find the ratio for red to blue of the perimeters and of the areas. I have so many of you guys forgetting to put two answers, so make sure you read the questions well, perimeters and areas. So that means you'll need two different ratios for this question. The first one says the perimeter, so we go ahead and see the sides that are corresponding and we know the information. I don't really know anything from here, so I have to use 6 meters and 8 meters. So I put red to blue, so 6 to 8. And actually what I'm going to do is I'm going to simplify the numbers as much as possible. So I can write it like this, 3 to 4, or I can write it 3 to 4. Either way works. So this is going to be for the perimeter. For the area, it's super simple. All you have to do is to multiply the same number twice or square the number and have the area of 9 over 16. So this is going to be the perimeter and this is going to be the area. Same thing for 6. You have to be careful though because it says red to blue. So even though the red shape is on the right side, you have to have the red shape first and then the blue one. So I have 28 to 16 and I'm going to simplify it as much as possible, which is going to be 7 to 4, or you can write it 7 over 4. And then my area is going to be the square of those numbers, so it's going to be 49 and 16. So these are your two numbers, and that's about it. The key point is to simplify your ratio for the perimeters as much as possible before you find the ratios of the area. For 4.3 lessons, we didn't actually have much of a video to go over it, but because we already know how to set up equations with proportion, we're going to review it quickly. So the key point of this is to make sure you have corresponding sides on the same floor. One of the questions type that people struggled with would be number 11. So I have two different shapes, and if you notice, my second shape is going to be upside down from this first one. So you can't use 8 and 26 together. You have to find the corresponding sides, which are going to be 8 and 25, and then x and 26. So let me go ahead and set up the equation. So like I said, it's going to be corresponding, so I have the 8 and the 25 together, and then I have x and 26 together. If you want to set up the equation in a different way, for example, putting the x and 8 together and 25 and 26 together, that's also fine, as long as your proportions are going to be using corresponding sides. After I set up the equations, I work with a butterfly because I don't have any numbers that would make 25 to 26 other than decimal numbers. So 25x equals 8 times 26, which will give you 208. And if you divide both sides by 25, x is going to be 8.32. If you're still not sure how to work on this question, try working on number 8, 9, and 10, and send me a message to see if you got them correctly. Number 12 and 13 is from lesson 5.4, where you use different ratios and also scale factor. It says use a centimeter ruler, which I know a lot of you guys won't have a centimeter ruler with you, so I'm just going to give you the length of it and try to find out the scale of the drawing. So the scale of this castle says it's 192 feet, but in reality it's going to be 4 centimeter. So what I'm going to do is I'm going to find out what my scale is going to be. So I know it's going to be 4 centimeter for 122 feet. And whenever you have a scale, I want to have my scale factor to be the smallest whole number, which is going to be 1. So for 1 centimeter, how many feet is it going to be? And you can work on it different ways. You can either do the cross multiplication or just say, okay, if 4 centimeter is 192, if I divide it by 4, how many feet is it going to be? Either way, your answer will come out as the same, which is going to be 48 feet. So my scale factor then is going to be, my final answer, 1 centimeter to 48 feet, and that is going to be your final answer because they're trying to have you find the scale of the drawing, not the missing x. 13, you have 6 centimeters for the bat, and supposedly it's going to be 30 inches, so the same thing happens for this one. So it's going to be 6 centimeters over 30 inches. If it's 1 centimeter for the scale, then what is going to be the inches for each centimeter? So either you do cross multiplication or simple math, your x is going to be 5 inches, and then your final answer is going to be writing your scale. So 1 centimeter to 5 inches is going to be your factor. 5.5 and 5.6, we have different transformation happening in these lessons. I think translation is probably the easiest one because all you have to do is to move your points or your shapes to the following position. So 3 units left, 2 units down. So you pick 1, 1, 2, 3 left, 2 down. So it's going to be -2, 1. And you can put the coordinates of the x prime. And for those who would want to find out these coordinates without drawing the graph, you can use a second way, which is find the coordinates of the original figure. So let's say I'm going to use w, which will have 3, 1 as the answer. And then for your numbers, you're going to subtract 3 from x, and then subtract 2 from the y. Because you're moving left, you subtract. You're moving down, you subtract. So you're going to have a number for y prime as 0, -1 because you moved left 3 units and down 2 units. If you're not sure, you can always double check and say, hey, is this going to be the right answer? And I can just check it by quickly counting 1, 2, 3 to the left, 1, 2 to the down, and it's going to be the same answer. So if you are wanting to practice a little bit, go ahead and pause this video and then try to find out the coordinates for y and z prime, and you can unpause it and check the answer. So this is going to be the final answer for x, y, z, w, and the primes of those points. You can always practice number 15 if you want to make sure that you understood this correctly. If not, we can move on. 5.6 is talking about reflection, and the first one we have is number 16. Tell whether the blue figure is a reflection of the red figure. So the red one is going to be the original and blue one is going to be your image. And reflection means mirror image. All you have to do is to see if these figures are mirror image of the original. Obviously, the first one is no, and the second one is yes in this case. One thing I want to add is reflecting over the x and the y-axis. So remember, when you're reflecting across the x-axis, the horizontal one, your x values are going to stay the same, and then the y values are going to change. If you are working with the vertical or the y-axis, your x will change and y will stay the same. The last part of this chapter was on rotation, and I think more people had a hard time with this. So first, 18 and 19 says, tell whether the blue figure is a rotation of the red figure about the origin. And we talked about how the origin is actually going to be the center point right here, 0, 0. So if so, give the angle and direction of rotation. So let's see, is 18 going to be a rotation of the first figure? And if you notice, it is not going to be, because this shape, red shape, just slide to the right, and that's going to be a translation, not a rotation. So I put no, this is not, because it was translated, not rotated. And then for the second one, I am going to see if it's a rotation, and when I look at it, it looks like a rotation because it's going to be on the opposite side, so it's going to be 180 degrees, and either clockwise or counterclockwise. Both of them work because either way you spin it, it's going to end up in the same position. The biggest indication that I know is going to be how far each of these points are going to be from the origin. In this case, they are equally distant from the origin, so I know that they're going to be rotated. Number 20 and 21, you actually will have to rotate the figure and find the coordinates. You can draw the points, you don't have to, for the first one at least, and then you may have to rotate the actual figure for number 21. So let's go ahead and take a look at this. 270 degrees counterclockwise. Counterclockwise actually means if it goes clockwise, it's going to be 90 degrees clockwise. And even the textbook only gives you the first quadrant so that you can just do clockwise. So let's look at the rules. When you're changing the coordinates 90 degrees clockwise, the rule is going to be changing the x and the y's position and putting the opposite of the x value for the y answer. So remember this for the 90 degrees clockwise. So what I'm going to do is I'm going to just look at the coordinate points and then see if I can just move them. So first I'm going to find out the coordinates of A, B, C, and D. So I have the points ready, and I'm going to go ahead and change these into the 90 degrees clockwise rotation. So my A prime is going to be the opposite, so 1, 2. B is going to be 3, 1. C is going to be 4, 3. D is going to be 2, 4. So based on the rules, these are going to be the coordinates of the second shape or the image. Now, if you want to make sure that you have the right numbers, you can either check the equation again, or you can actually plot the points and see if they are 90 degrees to clockwise. So I plotted the points, and then The way to check it is to see if your points are making 90 degrees angle. So let's say I'm checking A and then A prime. From my angle to origin to here, it's going to create a 90-degree angle, so I know it's a correct rotation. I think a lot of people struggle with rotating about a vertex, so I'll go over and do number 21, where you rotate your original figure into 180 degree clockwise about the vertex M. So when it's 180 degrees, it really doesn't matter which direction I go, but I know it's going to land on the opposite side of the shape. And M is going to be my point. So M is still going to be 0, 2 for my M prime, because I'm not changing anything for the matter of fact. And then what I'm going to do is I'm going to count how many units away my N and L is going to be. And the key point is they cannot move in diagonal action. You always have to move in straight motion. So for example, for N, although N and M are connected with a straight line, I can't move across. I have to go straight in this motion. So first I move 2 to the right, and then 3 to go up. So I'm going to do the opposite. So I'm going to go ahead and do the opposite. So since I went up 3, I'm going to start from there, 1, 2, 3, and then move out 1, 2. So this is going to be my N prime. And my M prime is going to be 2, 5. And then I work with L, which I'm going to move 1, 2 in, and then 1 up. So I'm going to do 1 up, 1, 2 in. So it's going to be on the opposite side, like here. And my L prime in this case is going to be 2, 3. And then when you connect all these dots, you can see that your original shape is completely upside down because it's 180 degrees. So hopefully this review makes sense to you. If you want to go over more on the rotation, please let me know so we can set up maybe a review session for those who are still struggling with rotation. Your homework is going to be page 244, which is your chapter test page. It's not going to be an actual chapter test, it's going to be your assignment. Please work on them. One thing that I want to mention is that for number 4, you have a fish here, and it says use a centimeter ruler to measure the fish. Obviously, not all of you guys will have that accessible, so I'm going to just give you the measurement, which is going to be 5 centimeter. Okay, so use 5 centimeter to find the scale factor of the drawing, and you'll be able to finish the questions all the way from 1 through 11.